Good afternoon and good evening, everyone, as you're joining.
Hey,
Happy Halloween as well. We will not be going the whole time today. I know some of you hopefully are getting trick-or-treaters or taking family trick-or-treating. Um, I know my wife did like an hour ago. So
Pastor, I have a question.
yeah, throw it out there.
If I wanted to withdraw from this class and take it next fall, would it be held against me? Because I don't know how I'm doing, and it's
That you don't know how you're doing because I haven't graded enough. You're probably doing better than you think you are. I started reading the projects, which is a good sign, and they aren't bad.
okay.
So Um, it would never be held against you if you take the course or drop it. There's existential crises that people have, right? But I think everybody that's engaged and is turning stuff are way ahead of the game. And the grade is not strict, especially with me being sick and us missing some stuff. I can't be, right? So there's going to be some flexibility.
Yeah, because I seen today you posted project two, and I don't know how to do project two because I don't know how I did on project one.
No, so yeah, that's I posted it so you can read. The expectation is pretty much the same. So it's just an extension. It's just you're gonna have to do more mathematics, right? So you confidence interval and a hypothesis test. So that's what the extra 10 points are. But I am grading your projects once. So don't worry. Those grades, everybody will have their grade by Sunday, hell or high water. So about half of you, I've downloaded them and I started reading the introductions and I'm just getting a sense of what people have written. Okay.
Okay.
But if you feel you need to drop, it is never held against a student if they drop.
Okay.
Okay. But I don't think you need to.
All right.
I'm feeling pretty good.
Okay. All right.
Okay.
Mhm.
And I apologize. Again, I'm doing the best I can with my circumstances, and it sucks for you guys all. It does, and I
Yeah.
recognize it. So. And you're welcome to degrade me in my evaluations because of
No,
it.
no, I definitely don't hold that against you. I just wanted the full experience.
No, no, and actually, in some sense, you're getting more of me than you think you are.
Oh, okay.
Because usually we'd have off and on, but since
Mhm.
we've missed stuff, I'm like, screw it. I just want to go full board.
Okay.
Um, yeah, you're definitely getting more.
All right.
Difficult. And to be honest, actually, we are on track,
Mm-hmm.
like material wise. We're actually a little ahead last time I taught the course because we haven't had so many off weeks. Okay.
Okay.
So, what I would recommend is don't worry about the project right now until you get that feedback. I would start on assignment 3. Okay.
Okay.
That which was posted. And the nice part about assignment 3, what it does is it's basically broken up into three pieces. One, talk about somebody's quick presentation they did. What was interesting about it, right? What do you think they could have done better? Number two, confidence intervals. And if you started now, the nice part is you can catch me for office hours or set up an appointment where we can say, you're struggling. I have my iPad here, which is much better to see the formulation and how it works, or we can work through how to do it computationally. Okay.
Okay.
So if I was in your shoes, the way to approach this is I can, the professor has posted the next big project. I can't do it until I get good feedback, correct?
Mm-hmm.
But I have an assignment that's due beforehand. Okay.
Okay.
That's how I would approach it. I know they're not as worth as much points as the project, but I think, and the nice part is if you understand how to do some of the assignment, that will help you with the project
Okay.
because it's confidence intervals and hypothesis testing.
All right. Thank you.
Yeah. Other questions. And by the way, she asked like one of the best questions. It was a very good question. I want to reiterate that. I know we won't have a full class because a couple people said, I need to take my kids trick or treating. I was like, you do that. Um, I'm just waiting if other people have questions. Okay, so the way it's going to work today is we are going to have a guest. Did everybody see target announcement that came out today, like the million of them that you get, right? We'll get like 5 million a day. Let's see. I saved it. It was about, I'm gonna pull it up. Sorry, just give me 1 second. It was about research with REST, REST. Did you guys see that on target announcement?
Yeah, I've seen it.
Yeah. So I mentioned last week that we were going to have people come to do presentations. The goal of that group is to help students like yourself who are doing statistical analysis for a project or research. So it's kind of nice. It's like it's another place to get help. So if I'm not there to provide you, or it's like my training's not available when I need him to be available, I have another place to go to help with your projects. So Heba knows a little bit about this. They're supposed to be coming to class today. So if they don't, then Heba is going to give us a little more information about it. Okay.
Yes, sure, Professor. I can. Do you want I can follow up with them?
Yeah, find out, because I think you have their contact information.
Yeah, I'll do it. Thank you.
And make sure they have the link for meeting today.
Okay, okay. Let's follow up.
All right. Let us finish hypothesis testing. And before we go on to the next type of hypothesis testing, can anybody in their own words, it doesn't have to be mathematic or whatever, what is the goal of hypothesis testing? Anybody, go ahead, throw it out. I can't see everybody. Is that you, Troy, that?
Yeah. Is it to prove that your hypothesis had no effect whatsoever on the outcome?
Yeah, okay. I like that. Yeah, we're saying we did some intervention and we want to know, did it have an impact, right? Okay. Okay, that's pretty good. Anybody else? Again, it's
To determine maybe if it could be accepted or rejected.
yeah, this hypothesis, right?
Hmm.
Yeah, so yeah, yeah. Okay. Anybody else? These are good. These are great, actually. Okay. So I agree with what Ivory and Kelly were saying. One of the ways I think about it, I'm throwing out my thoughts, is I say, you know what? I did this intervention and I don't know if there was a significant change. And the key word there is significant, right? It might look like it. The eye says, oh, yeah, definitely. That intervention worked. But you don't know if it's because there's a lot of variation in the data, correct? So if you do a weight loss intervention and you have one person that loses 10 pounds, another person that gains 10 pounds, maybe it's a wash, correct? And maybe the data is so spread out, the standard deviation is so big that the intervention really didn't work, even if it looked like from the eye candy. I say eye candy because my kids are eating candy right now. Okay. So let's kind of think what we're thinking about is are we sure with some confidence that there's a statistically significant difference? So what we're going to do today is we're going to continue these different types of methodologies. So I just want to go back. Let's go way, way back. So recall that what we do is our procedure is we have a null hypothesis, research hypothesis. The alpha is almost always 0.05, right? So 95% confidence. We have to select the appropriate procedure, which depends on what?
The sample size
Yeah,
or
yes, sample
population
size is one.
size?
Right? Go ahead. What else, Ivory?
Population, if we're dealing with populations,
Yeah, sample
right?
size, population, I agree. What's the other? Sample size is one. It's not written what the other is here. Well, are you comparing averages, proportions, many different averages? You know, my weight loss and my heart rate. Like, what are we comparing, right? So what do you, we have a kind of a phrase for this. A very key phrase. You all need to eat more candy. Go ahead, Kelly. Throw it out.
Is it dichotomous or continuous?
Yeah. We call it the type of data, right? Like it's really important. You have to know what the data is. Is it averages? Is it proportions? Is it categorical, right? We have this new thing called categories. Next, we set up our decision rule. Then we do the actual calculations. And then we make a conclusion. Our conclusion is 2 or 3 sentences. And then finally, if the null hypothesis is rejected, we have a p-value. So this is your procedure every time. And I highly recommend when you're doing the homework or the assignment, do it this way. Step 1, step 2, step 3, step 4, step 5, step 6 for every hypothesis test, no matter what. And even if you can get 1 and 2, be like, I am stuck on 3 or I'm stuck on 4. Can you help me? I'm like, I know why you're stuck. Let's talk about it. Okay? But go through each step. So what we did last time is we did this continuous data. We did 1 sample, 2 independent samples, 2 matched samples. So 1 sample is like, we're looking at the weight loss. 2 independent samples is we're looking at the weight loss and I don't remember what the example was. I think we had blood pressure and something else. And the next was like we had blood pressure before and blood pressure after. And then finally we ended with ANOVA. And remember ANOVA, you have to do it by a computer. And there we had blood pressure with this medicine, blood pressure with a different medicine, blood pressure with a placebo, and we tested those. What we're going to be doing today is looking at proportional, right? So a percentage for 1 sample and 2 independent samples. And then finally, we're going to do something really cool, which we haven't done anything. We haven't done it for confidence intervals, but categorical data. Okay. And it's actually something I use a lot. So, all right, let's get back to it. All right. So let's start with this 1 sample. And again, one of the nice things I highly recommend is download these slides, right, as you're doing the homework, and at least you have a guide. And it tells you what section you're in. So you identify the data, it's a proportion, it's 1 sample, 7.3. Dr. Hibden did an example. Let me also see the examples in the book. I still don't know what I'm doing. That's when you emailed me very quickly, like, I'm lost, help me. Okay. This is it. So one of the criteria is that n times the proportion and n times the other proportion are greater than 5. Typically, I don't even test this. I assume this is always true. And here's your test statistic. Notice we only have a z-value. So I made it up an example. And I didn't change my number. I thought I changed the number. I didn't save it. So a pharmaceutical company reports that 85% of their patients had no side effects from a drug. By the way, how many of you trust pharmaceutical companies? Some of you work for them, so I'm teasing. A university tested this on 100 individuals, and 78 said they had no side effects. Okay, so I have 78% said no side effects, but the pharmaceutical company said it should be 85. So the question is, this number should be 85, by the way. Oops. So can we reject the pharmaceuticals claim? Right? That it was 85%. They said 85. I did my own test at 78%. And the question is, should we reject that claim? That's a legitimate question, right? You work with children, and it says that 90% of children that do after-school reading have a bump in their reading level. But then you do it in your school, and you're only seeing 35% or 40% or 70%. Do you agree with the claim that was already made? And even if the numbers say, no, I don't agree with it, right? We still have to test it. That's what Kelly and Ivory were like. That's our goal, right? About these tests. So what's the null hypothesis? What are we saying the proportion should be? If there's no difference.
%85,
Okay, what's the alternative?
78.
Close. We're saying that it's not, right? So just take what you did with the null, it says it's 85, and say it's not 85. And what's the alpha value? It's not a trick question, it's there. Come on, somebody else that hasn't talked. This is like a layup. Fine, I'm going to call on somebody. Bonita, what's the alpha value?
Is it 0.15?
Why would it be 0.15? What does it say in the paragraph? That's a good guess.
Okay, well,
So remember, it's always going to say it in the statement. So what does it say?
oh,
in
I'm
the-
sorry. So the alpha on here is 0.05.
Yep.
Okay.
Yeah, no, that's okay. That's why we're practicing. Thank you so much, Benita. You're my guinea pig. Yeah. By the way, it should be 85 because this should be 85. Okay. No, proportion's 85, not 85. The alpha, if they don't give it to you, it's 0.05. They give it to you, it's going to be 0.05. All right. Appropriate test statistic. The n is 100. I do calculate the min of this, but to be honest, it's always going to be this, or you can't do the test. And then all I did was I put in the formula that we have up here. That's it. So we're going to reject the ANOVA if the z is less than or equal to 1.960 or greater than 1.960. Notice this is two-tailed. Why is it two-tailed and not one-tailed?
Because it's less than or equal. It's in the center.
Yeah, exactly. It's in the center, right? We don't care if it's greater than or less than. That's right. Because if we look at our alternative, all we're saying in the alternative is it's not equal to that value. Yeah. So that's the center. That's very good. That is so good. That's one of the hardest concepts to get down. Yay. All right, let's calculate it. And we get a z value of 1.9603. minus, and you're like, woo, that's pretty close, isn't it? But that's less than. So look at sorry. So it said we reject it if the z value is less than that value. So notice, even if it's close, we're still rejecting that null hypothesis. We have statistically significant evidence on an alpha value of 0.05 to show that the pain reduction is significantly different than 85%. Okay. The p-value, oh God, I could have swore I changed all this. This should be 0.049. So before I load these slides up again, they're already up on D2L. But before, I'll make some changes so that they represent the right values. How cool is that? That value is so close. So close. All right. Now, let's do two independent samples. And again, what we're looking at is a dichotomous outcome. So we're going to compare two independent group samples of proportions. There's multiple ways to do this. And this 7.7, you will see this in papers you're reading. So the top one is just the straight up proportion. The null is proportion 1 equals proportion 2. The alternative is proportion doesn't equal proportion 2. There's a new thing called the risk difference. Has anybody seen that in any of the papers they've read? Or relative risk? Anybody seen that before? Okay. So the risk difference is saying that the null is the difference between the two proportions, or the two different tests is 0. So we're looking at risk, right? So we're saying if I do one thing or the other, am I changing my proportion size? So that's why we call it risk. And then the relative risk is actually saying P1 divided by P2. We call it relative risk, is what we call it. Okay. So let's do an example. So can somebody read number 6 from page 165?
A clinical trial is conducted comparing a new pain reliever for arthritis to a placebo. Participants are randomly assigned to receive the new treatment or placebo, and the outcome is pain relief within 30 minutes. The data shown in table 7-54, is there a significant difference in the proportions of patients reporting pain relief? Run the test at a 5% level of significance.
So what I was going to have you guys do is go into groups, but it appears that people are tired. And very, very tired. And also it's Halloween and probably want to be doing something else than this. So let's so what I would like for us to do is, without me doing it, what's the null hypothesis? What's the alternative? And what's the alpha value? So that's step 1. Come on, someone new, or I will call on people. And it's okay to be wrong. We're here to help each other. I learn from my mistakes all the time. Oh my God, you should have seen me teaching this morning. Go ahead, Smaya.
So for the null, would that be that there would be pain relief um, within 30 minutes? And then for the alternative, would it be that there won't be pain relief within 30 minutes?
Okay, I think you're on the right track, but I would switch, right? Remember, null means no change, right?
Oh, okay. So no pain relief within 30 minutes from the,
Yeah, and yeah, you're on the right track. But remember, we're working with proportions, right?
yeah.
So yeah. So I don't know how to do proportions of pain relief. How would we do that? Don't leave Samaya hanging. Everybody got to help out. This is a group effort. I can always break you up into groups and I can go eat a bunch of candy, which I won't because I'll throw it up. But Samaya started us off a little bit. Remember, we're looking for portion.
You said how would you measure pain relief?
Well, my question is, right, the null is like they give us something, right? Not everybody gave pain relief. Did they all 100%? What proportion got pain relief?
When you look at the chart, it say 44 people got pain relief.
Out of how many?
Somebody out of how many people?
Mm-hmm.
I don't know, gotta add it up.
Help her out. Help each other.
So would this be the percentage of people that got pain relief with the new medication being the same as the percentage of people who got pain relief on the placebo?
Yes.
Okay.
So let's find that percentage. See, team after. Samaya set us up. Jara steered us in the right direction. Kelly finished us off. Now we just need the actual percentages.
Would you, how would you find the proportions?
Well, how many people were in the test? How many people got the drug and how many people got the placebo?
Mm. Also add it all up.
And it could be in the paragraph too.
No, I don't think it was in a paragraph. It wasn't.
No, I know.
So add up all the participants that was in it. If I
Mhm.
add up, if I add up everything, it was 232.
Okay. 232. And was everybody, so who was in one group and who was in the other?
The people who got the medication, 44 people got pain relief and 76 had no relief. In the placebo group, 21 people had pain relief and 99 people didn't have pain relief.
So for the medication, it's 44 out of how many?
76.
76 plus 44, right?
Mm-hmm.
Which is what?
120.
120. Yeah. Yeah. Okay, good. Okay. So doing the same thing. I'm just gonna join with my tablet. so we can show how to do this by hand. All right. Come on, help out, please.
Oh, 120. Sorry, it's 120 for both.
Yeah, there. I was like, I'm missing something. I can't be missing. I don't know why my tablet won't let me join. Oh, I know why.
So are we doing 120 divided by 44?
Would that give you a percentage?
36%.
Close. Maybe the other way around. Remember, smaller number over larger number.
Well,
That's okay. Actually, that is a mistake I still make to this day. Sometimes I'm like, what am I thinking? Why am I doing this? So it's all good.
All a number? So it's not 36%?
Well, I don't know. What's 44 over 120? I need two people to agree. You always have two people to agree.
0.37. Oh, yeah, 0.367.
So I would round that up to 37%. Okay. Yay, I can join. I have to just let myself in because I want to show you something. And what did we get for the other percentage?
64%.
I think it's 0.18. 21 divided, what percentage we doing?
Yeah, this is a good question. You could ask each other, help each other out. I think it's so important. You learn from each other.
All the people who didn't get no pain relief from the new medication, right?
Yeah,
Okay.
I think.
Yeah. Okay. That's great. There we go. I'm coming. Okay, so you said we had 44 out of 120, right? Which was approximately 0.37, or right?
Yes.
Got pain,
Yeah.
got pain relief, correct?
Mhm.
From the medication. And then for the placebo, we got 21 out of 120.
Yeah, and it was 0.18.
I need one other person to agree.
I agree.
I agree too.
So got pain relief from placebo. And the question is, what do you think? Is the med better than a placebo? Even before we do any statistics, what do you think?
It looks like it's twice as effective.
It does. And I'm feeling pretty good about it. Right? But we got to prove it to the establishment. And the way to do that is a hypothesis test. Right? So our first step when we do this is we got to state our null, our alternative, and what the alpha value is. So the null says what?
0.37 is 0.37.
Okay. Yeah, we're on the right track. So I think one of the ways I do this is I say, I'm going to let P1 be the meds, and P2 be the placebo. Okay? And what we're going to say is that the null, right, means what? Irregardless of this test, null means
No difference.
no difference. So we're going to say that P1 equals P2. Okay? And if you want to write this in words, you say there is no difference in pain relief between pain meds and placebo. And that's what we're going to test. And Kelly and I agree, it appears that that's going to be wrong. So we're hoping we reject it. Bless you. You don't have to mute, Ivory. So what's the alternative?
That there is a statistical significant difference between the pain relief medication and the placebo.
Yeah, and we have to look at the question a little bit too.
Oh, hello. I just connected by mistake because I was preparing materials for tomorrow departmental meeting. How
Okay.
are you doing, Dr. Hibdon?
We are having fun. We are trying to understand hypothesis testing for difference of proportions. So we're having a really good discovery that working with proportions can be fun, but also frustrating. How is
Yes.
everybody feeling about hypothesis testing so far?
I'm glad to hear that. So I will be disconnecting quickly, and good to see all of you, and good to see you, Dr. Hibdon. Okay,
Thank you,
good
Dr.
luck with
Files.
everything.
Bye. So if people don't know, Dr. Files is the chair of the math department, but she also runs the CHECK program, which looks at cancer health disparities in Chicago. She's also a very famous researcher from does a lot of work with in Poland. And there's a big extra credit opportunity coming up. Did anybody see another Target announcement about the modeling workshop? No. Read your Target announcements. You all kill me. Okay, you get like 20 of them a day. Still look at them. I'm going to post that one on D2L. If you go to one day, you get extra credit. That'll count towards like attendance and stuff. If you go the second day, you'll get extra credit. That'll count towards your projects, actually. Okay? 10 points for the projects. So if you didn't feel like you did well. All right. So this one says, now are we looking for a decrease or an increase in pain relief? Or do we just seeing if there's a difference? What does the paragraph tell us?
Is there a significant difference in the proportions of patients reporting pain relief? Run the test at 5% level of significance.
Cool. So we're just saying the alternative is P1 doesn't equal P2. And what does alpha equal?
0.05.
Yeah. And you're like, it's always 0.05. Why is it always 0.05? What's step 2 for us?
Select something to do the data with.
Yeah, it's called appropriate statistic. Okay. Now you should be asking, well, Dr. Hibdon, you didn't tell us which one we are doing, did I? Did I tell us like what test statistic this works for?
No, but it's 2, so is it?
I kind of just left it here, didn't I? So notice in every example we've done, I've like had this this table, correct? How are you going to find it? I left you hanging. What do you do? Besides sending me an email, it says I didn't teach you it, which is true. Go ahead, Ivory, what were you thinking?
was thinking we either gotta do a T test or a Z test, or no?
No, you're thinking in the right direction. But where are we going to find the appropriate like formula? That's what we're looking for, is the appropriate formula. So where do we find that? So Ivory's right. We got to figure out which, but where do we find that formula?
I'm guessing in the book.
There we go. Yes. No, and I'm teasing you, but notice I'm pointing something out. I'm trying to guide us in a way so that if you feel like you're lost, you're not as lost as you think you are. So what section are we looking for?
Two independent samples with two different outcomes.
Yeah, what section is that one?
7-7.
Yeah, let's go to 7-7. You can also look at the very back, the last, right before the sample problems. So if you look at page 164, that might have it too. It's 164, 163. Again, everybody should be engaged with this. We're just looking for the formula.
Is it P1 equal X1 divided by, is this right? No?
Are you showing me? Let me stop sharing so I can see. Where are you showing us, Tiara? You can put it up to the screen if you want. Move it to the right. Other right. And up. Not quite. Not quite. Not quite. I want everybody to be looking.
So if it's more than 5 successes,
Mhm.
never mind.
No, go throw it out there.
Is it this one?
No, not quite. You're looking for a z value, a z calculation.
Oh, it's long. Oh, is it table 717?
Yeah.
Oh, you want me to say it?
You should be seeing something like this. Z equals,
What's
I
the
believe,
triangle above the P's?
what?
What's the triangles above the P's?
Oh no, I'd have to see it. I don't have my book, or I can't even get to class. I don't know. Let me I don't know. I don't have the book with me, but let me give me a second. You should be seeing something like this.
Yeah.
Is this right?
Mm-hmm.
Okay. Where P and there's different formulas, but this is the one I like. Okay. Well, what is the P1? Well, we just need this, right? We don't have to do any calculations. Is that correct? You all agree?
Yes.
And is this the formula you see in the book? There's multiple formulas.
That's the one that I see in the book.
Okay. Oh yeah, and Heba, the one you have is for that's the chi-squared test, I believe. Okay, and that's what we're going to be doing next. All right. So this is our formula. Remember, so what we've done step 1, step 2. What's step 3?
Set up a decision rule.
And what is it?
To reject if
Reject the null. If what? You can look at the book, do whatever you need to do to help you.
we're rejected if P1 doesn't equal P2.
Not quite. Remember, it's related to the z value. We're going to reject if it's less than or equal something, or z is greater than or equal to something because it's two-tailed. And you need to figure out what those z values are. And I expect everybody to participate. I'm gonna, again, I'll call on people.
How do you figure out the Z value?
So what has it always been? Or one of the things that I would do is I would look in the examples too. Again, the goal of this is getting us into a habit of looking at the examples they do in the book. Yeah, so Maricela actually brought up a good point. If you're confused, I need you to say you're confused. I'm assuming that nobody has said anything because they understand it all. And every professor will always assume you understand unless you say you're confused. So, Maricela, tell me where you're confused. Eva, tell me where you're confused. So you got to talk up. I can't hear. Sorry.
When it comes, oh, can you hear me?
Yeah, we got you, Benita. Yeah.
Okay, sorry, my thing keeps going out. Okay, when it comes to the Z value, don't you just reference to the back of the book?
You do.
Okay, okay,
The value is going to be one of two things, by the way.
okay.
Yeah. Eva, where are you confused?
Okay, so right now I'm confused. Um, like you are more talking in the mathematical language, and it's difficult for me to perceive it.
Okay, which part? Help me out. Step 1,
Like
2, or 3.
yeah, from the beginning.
So where? So which part of step 1?
So the first part we did, it was clear in my mind. Now, like now when we were doing the second part where we were applying the formula, in that part I'm like stuck. I don't know. I'm
So we
not
didn't apply it. We just wrote down the formula, right? We haven't
okay,
done
but
any, so we have to figure out what formula to use, right? So this is good.
okay,
So no, you're right. So one of the things I want you to get in a habit, you're not doing any calculations. There's no math until you get to
okay.
step really 3. But all you're trying to do is figure out what is the right formula to use, correct?
Mhm.
And I think that's when you guys were sitting there, I was waiting. We have to search it in the book sometimes because it's like, oh man, which one am I doing? Is it 2 proportions? Is it 1 proportions? And you have to be able to look it up because I can provide it, but a lot of times you're going to forget or you're not going to understand. So one of the things is this piece right here, this comes from the book.
Is the Z
Yeah.
value 1.960 if it's two-tailed?
Yeah, but we'll come back to that. I just want to make sure everybody's. Sorry, gonna. Okay. So does that make sense, Siba?
I'm catching up.
No, you're fine. And if you are confused, you have a responsibility as a student, especially as a grad student, say, what the hell is going on? And step up. So,
Mhm.
Marcelo, tell me where you're confused. And we can start from the beginning as well. We need to make sure everybody's on the same page. And I love it when you guys say you're confused because it guides me where I can focus. Otherwise, professors and teachers are freight trains. So Maricela, tell me where to go. Where should I guide where the confused? That's okay, Maricela. You can write it in the chat too. I'll be patient. And if anybody else is confused, speak up. I really want you guys to speak up. This stuff is complicated. It's not something that's like, I'm gonna get it right off the bat. Okay? And it's okay. But if we're confused, we need to talk with each other. And the nice part is if you need more time, we can find time in office hours to do more examples. Yeah, I agree. And Marisol, I agree. More practice is definitely needed because we only have time for 1 or 2 examples, right? And the examples I've chosen are not ones that are examples done in the chapter. So the nice part is you at least have 3 examples per type of topic. And one of the things is we can review one of them together and we can go step by step. So if you want to do that outside of office hours, this is for everybody, just not Maricela, because she's not the only one that's confused. And I don't want to put it on her. It's on everybody. Okay. So I want to make sure we're in this together. So my question for you, if not two-tailed, what would Z be less than or equal to?
So when you say that it's not two tail, are you talking about being one tail?
Yeah, and in that case, what we're saying is P1 is less than P2.
It would be 1.645, right?
Yeah, minus.
Minus.
Or P1 is greater than P2, and that's Z is greater than or equal to 1.64. Okay. Those are pretty much the values for the Z values. All right. So what have we done? Okay, I'm about to lose my tablet. This is not good. But let's get through this example before it crashes on me. All right. So we've set up our null and alternative test. We've chosen what we think is the appropriate calculation. We've set up our decision rule of how we're going to reject the null hypothesis. What's step 4?
Put the information in.
Yeah, calculate test statistic. And when I do this, I'd be honest, this is what I do. I say P1 equals something, P2 equals something, N1 equals something, and N2 equals something. This is what we need. What's the P1 value? It'll help us out. P1 is 0.37. P2 is what? Anybody write it down?
0.18.
0.18. Yay! We have an agreement. What are our ends? Yeah, you got it.
That's the sample size. Is it 120 or two?
How many people?
240.
It was 120 in each, right? But yeah, 240 total. Cool. Now, if I go up to the calculation here, it says, I got to calculate this guy first, don't I? That p-value. So we're going to say P equals P1 times N1 plus P2 times N2 all over N1 plus N2, I believe is what it is. And all we do is we plug everything in.
Mm-hmm.
Oh, I'm sorry, it keeps moving. Kaylin, sorry. Plus 0.18 times 120 all over 120 plus 120 is 240. And all you do is you plug this into a calculator. So you're going to get some p-value. Something, right?
Yeah, so I got 64.8 divided by 240 equals 0.27.
0.27. Okay, cool. Anybody agree?
You said you got
Good job,
60 over what? I didn't hear you. You'll repeat it again.
I get 64.8 divided by 240 equals 0.27.
Yeah. By the way, I know that this value is 44 and this one's 21. I'm cheating. So yeah, 64 is really, yeah, that sounds about right because we rounded stuff. All right, good job, Ivory. Got us. Got us going. Okay, but that's not all we need, right? We need the Z value, don't we?
Mm-hmm.
So the Z value is P1 minus P2 divided by the square root of P times 1 minus P. Sorry, I don't have these formulas memorized. Times 1 over N1 plus 1 over N2. Okay? And we'll just plug this in. So it's 0.37 minus 0.18 all over the square root of 0.27. What's 1 minus 0.27? Yeah, your p-value has to be less than 1. Note, p must be less than 1. 0.37 or 0.73. Yes, good. Okay. And then this is 1 over 120 plus 1 over 120. And again, I can't do this in my head. There's no way I can do this in my head. I have to plug it into a calculator. Okay. I know it's positive, by the way. That's all I know. I'm going to show you how I do it. I'm going to go to Desmos and I'm going to go 0.37 minus 0.18. I can do that one in my head, but you know what? I'm lazy.
What's Desmos?
Oh, it's an online calculator. I'll provide a link in on D2L. It's something we use in math a lot.
I get 3.29.
Okay. We need a confirmation. Always need a confirmation. I think that's really close, Ivory. I think that's right.
With Desmos, you can enter the symbols too.
You can, but it's a little messy.
Oh.
I'm gonna lose it. You guys are gonna get so mad at me because it's gonna break. Sorry. That looks like right for the denominator. Then we're just going to do 0.19 divided by 0.03285. And I got 5.783, but I think maybe if we rounded more, right? So I got this to be 5.783, but I could be wrong. Okay. Are you guys seeing anything? Come on, wake up. But it doesn't matter. I mean, we're kind of close. Is this number bigger than 1.960? Ivory's and mine?
Yeah.
All right. So what do we do? Step 5, conclusion. What do we say? Do we fail to reject or do we reject?
We reject.
We reject null hypothesis. That is, there is significant evidence that there statistically significant evidence that there is a difference in pain between the medicine and the placebo. And Kelly and I were right. Woo! Our instincts were right. It does appear to be. What's our last piece? And we're not going to be able to do it because my computer is going to crash, or my tablet is. What's the last piece?
Submit it.
What?
I said submit it.
Submit it. We actually need to find the p-value, right?
Oh, this is a lot.
But you always have to find the p-value, and you do this in R or Excel or whatever. There's even online free ones. You can just say, give me the p-value for a z-value of the following. Okay? And the formula of how to do this in R is given on every example we've done so far. Okay? And it's about to die. It's about to die. Okay? So I apologize. Would it be helpful if I provide those slides that we just wrote on?
Yes.
Is that okay for everybody?
Mhm.
Yeah, I got a
Yes.
yeah from Zubia and Hiba, from Tiara. Okay, awesome. I'll put them on. Okay. We need it badly.
Professor, so is it that you only provide a p value if there is a difference? Like if we accepted
If
the
we
null?
reject null hypothesis, well, I want you to have it always get a p-value.
Oh, okay.
But
How do you find it again?
if you always get a p-value, but all the papers you read, everything that we ever do will always say the following. And they will only show it if we reject the null hypothesis. Okay, that's it.
What's
Every time it's if we reject the null hypothesis.
what's the p-value?
The p-value is saying, remember, we're comparing for the alpha value, right? Because the alpha value that we're setting as our standard is 0.05. And the p-value says, where are we relative to that? If we're less than that, we're rejecting the null hypothesis. Let me share my screen. Oops, sorry. Wrong PowerPoint. I'm going to write that down for us. Oops. Escape. Come on. Why did it do that? Can you see the slides? So I'm going to get this. The p-value says how much are we away from the line that is set by the alpha value. If p is less than the alpha, then we have rejected the null hypothesis. Okay? And we're just saying by how much, right? I mean, you're not really saying that. You're saying the p-value is 0.01. I don't understand. To be honest, I've asked biologists because really this is biology and psychology realm. Mathematicians don't care. And I said, why are you giving the p-value? They're like, well, we're showing how much of a difference. I was like, if there is either a difference or there isn't. I've never got a good answer. And I've asked some of the people, I've asked a person that has one.
So early on when they decided to,
A Nobel Prize. Okay. This is your discipline. Go ahead, Kelly.
oh, sorry, no, just so back at the beginning when they decided to use the letter P to represent proportions, and we were doing P1 minus P2, it was a little confusing because that is a value of P at that time, but that's completely different than what we're doing now at the end as a P
Yeah.
value.
This p-value is is a probability value, not the p-value, not p1 and p2
Okay.
given above, which are related to the data. Okay,
Thank you. Thank you.
this is helpful. This is helpful. I'm writing this out for you.
What's the answer?
I didn't calculate it. I didn't calculate the p-value. Do you want me to do it?
Yes.
Like, Dr. Hibden, give me values. Okay. Yeah, I'm gonna cheat because I'm gonna pull up my code. I should just share my full screen. We are going to take a break in a second. I thought they'd be here already. So to get it, we just plug in the P norm of our Z value. Z value. And what did we get? What was our calculated Z value? It was like 5 something.
It was two different answers.
But let's choose 5, right? I think the value I got is right, but Ivory could have been right too. Okay. And you're like, wait a second, that's bigger than alpha. Well, you actually want to do 1 minus P norm because we've been above, we're above. And this is it. What you are is you're on the high side of the bell-shaped curve. If you're on the bottom, this would be fine. If the values are negative, you don't need the 1 minus. That's a really small p-value, isn't it? I think that's really small. Okay. Do you guys need to take a stretch break? I need to go stop my children from eating too much candy. So 5 minutes. If our guests come, Iba, do you know if they're coming?
I emailed her. She responded. She is not coming this week. Maybe next week.
She's killing me. Okay, why don't we take 10 minutes? Back at 7:33. Stretch, biological breaks, water. Tell your family goodbye that you're stuck in math for the rest of your lives. Hey, by the way, you all are doing great, and I appreciate so much those that talked on says I'm lost. Thank you so much. It is so helpful. All right, 7:33. Hey, Tiara, you're the first one back. So, did you dress up for Halloween? Did you
Yeah,
get trick-or-treaters?
I dressed up as a mom, but my daughter was she was Robin Hood.
Yeah,
Yeah,
I
I didn't
love
go
it.
trick-or-treating because I was in class, but my husband took my daughter trick-or-treating.
Oh, that's yeah.
Yeah.
I can't walk very far right now, still being sick. But yeah, my kids went.
What were they dressed as?
My 8-year-old, well, he'll be 8 tomorrow, dressed up as a bat,
Mm-hmm.
and my daughter dressed up as a flying cheetah.
How old
So
is
she
she?
had a cheetah costume and she had wings.
Mm-hmm. How old is your
You
daughter?
know, she's 5.
Oh, my daughter just turned 8 like 2 weeks ago.
Oh, so she's second grade, right?
Mm-hmm. Yeah.
Yeah, yeah. It's a good age. That's fun. It's fun. But you get to eat some of the candy.
Yeah. Snickers is my favorite. Snickers and gum.
Oh, yeah. The fungus actually changes your taste buds.
Mm-hmm.
I've tried a few of the candies. It tastes
Don't take
terrible,
anything.
and it's frustrating. I'm a big guy, so I enjoy
What
candy.
about food?
It's changed it a lot.
Mm-hmm.
So, which is also very frustrating. Um, like I had soup and that we put some a dollop of sour cream on, and I couldn't eat the sour cream. It tasted awful to me.
Wow.
And
Yeah.
I grew
See,
up in Southern California. Sour cream should be on some tacos, street tacos.
I never heard of it on soup though. I heard it on chili.
Yeah.
Yeah, but that walking pneumonia has been like I read seen on news that's been going on like grade school kids.
Yeah,
So
so they have a bacterial infection,
mhm,
which is awful. Mine's a fungus, and
mhm,
I think I mentioned last week, only about 200 people a year get it in the country,
yeah.
give or take another 100. Um, and so I will have this for a while,
They said it
unfortunately.
take about like 6 months, right, to fully recover.
Yeah, and then I have to take the drugs for almost a year and a half. And the
Mm.
drugs have a lot of side effects. Kelly, did you dress up? Did you dress up for Halloween? Kelly's laughing.
Oh no, no, no. Not
No,
a
no.
Halloween guy.
Yeah, I just do it for my kids
Yeah.
and the candy for the trick-or-treaters. Anybody else dress up, Anand? That's impressive. Yeah, and Maricela said she didn't. She didn't. Yeah, I mean it's mostly if you have kids, or if you're like in that mid-20s, right? Uh, yeah, I agree. Anybody else? Actually, I had a student in class this morning. She was dressed up as a crayon. I wasn't we were virtual, but she was a green crayon. It was cool. But she's also in her mid-20s, which is kind of representative. All right, let's get back to the grindstone. We are not going to 9. Again, you can hear my voice. It's starting to, but we're going to finish up these hypothesis testing. The last 2 tests we're going to do is categorical. And I asked this question, what is categorical data?
It's like when you separating like people in categories, like male,
That's 100% correct.
female,
It is
race.
what you think it is. Can you give me an example? Anybody? Or Tiara, since you were
Right.
talking about
Race.
Like we categorize, yeah, like age, gender, in that way.
race? Yeah. Go to the hospital, pain, right? So what are the, so yeah, categories occur a lot. And notice the only thing we did with categories was at the very beginning of the semester when we talked about graphing, right? And we talked about bar graphs and we had them in categories, didn't we? That's the only thing we've been doing with it. So if you have categories, you can only graph it. And now we have a test. Is there a difference between the categories? If I take the population and break it up between those that are older than 50 and those that are younger than 50, I've now put the population into categories. And is there statistically difference in blood pressure between those that are in category 50 and those that are above 50 and those below 50? That's a good question, correct?
Yes, I think.
Yeah, I don't know. Probably not. But those above 50 probably have higher blood pressure. But little kids have very high blood pressure too.
Yeah.
All right. So what we're going to first start with is one sample, and we call this categorical or ordinal. Ordinal means just giving values to things that don't have value. So for example, race is a good example. Race doesn't have a value, but we can say people that that are black have a 1, people that are Caucasian has a 2, Native Americans a 3, Asians a 4, and so on and so forth. So we're giving values, and that's called being ordinal. You're adding a point system in some sense or whatever. But typically, I think more of it as putting things in categories. So what this is called is a chi-squared. This little weird X here, it's called a chi, C-H-I, and I'll type that in the chat. I can find it. So it's C-H-I. Okay. And we pronounce it chi. And we call it a chi goodness of fit test. And so what we're going to do is we're going to compare observed values to expected values. And so the observed values is from me being sitting there and observing or getting the data, correct? Expected values comes from, so let's say I'm doing an observation on 50 people, and I put these in this category. Expected values come from either a giant report on thousands of people, or we have the ability to calculate expected values from collected information. And the question is, does the distribution of response fit the population? Does the observed fit with the expected? And that is the question we're trying to answer. It's not much different from all the other tests. For example, the last example, does the proportion match for those that are in placebo versus not the placebo? Here, does the observed match the expected? Okay. So can somebody please read number 29 from page 169? It's a weird problem, by the way.
Did you say page 169?
Yes. Yes, Zubia.
Is it the same book? Do I have a different book? Because on page 169, I see the start of chapter 8.
Well, then go to 168. Could be my mistake, or it could
168,
be
I
just a
have
different.
maybe references. Okay, which question is it?
Number 29.
Okay, I see number 29. Some scientists believe that alcoholism is linked to social isolation. One measure of social isolation is marital status. A study of 280 adults is conducted, and each participant is classified as non-alcoholic, diagnosed alcoholic, or undiagnosed alcoholic, and also by marital status. See table 7-65. Is there significant evidence of an association? Run the appropriate tests at a 5% level of significance.
Very good. Thank you so much, Zubia. So what I've done is I've created a table that represents the data from the problem. Okay, so I've just kind of reproduced it. And we have married people, so 116 married and 164 not married. So they're saying, there's isolation for those that are not married. By the way, do we have a problem with this test or this? Anybody have a problem with? Anybody have an issue with this problem? Right off the bat.
I seen that it was 3 categories.
And we can deal with 3. But yeah, that is one thing. What else?
In
Do people,
total,
the total maybe? Yeah, it's 280, but yeah. Are people honest about the alcoholism? Go
No.
ahead. Anant, go ahead. Yeah, and as Ivory was saying, no, people are liars that are alcoholics. A lot of, and it's no, it's true. It's not to be mean if people are alcoholic, but they are because and you know and somebody that says they're an alcoholic will say we lied to ourselves. Okay. Not only that, what does it mean to be an alcoholic? As Anant was saying, I don't know. There's probably criteria, medical criteria, but I don't know what it is. Um, that's a good question. Actually, don't know that. I don't know much about alcoholism except for I know a lot of alcoholics.
Yeah.
Exactly. I mean, right? I do know one criteria is that they feel like they can't go a day without drinking or being around alcohol. Um, but my other question is, do you think it's true that if you're not married that you're in isolation? That's what they said. One indicator of isolation is marriage.
so through this survey, maybe through this survey result, it seems yes.
Yeah. Yeah, maybe. And that's a good point. It does, but maybe, but you know, I always question that stuff. And it's okay to question what has been done. And one of the things that I want you to do for your project too is question it. You know, they present the data, you're doing the analysis, but you should also be saying to yourself, I also don't agree with what they're saying. You can't disagree with the data, but you can disagree with the analysis or the assumptions. And to be honest, there are plenty of people that are married and feel isolated. There are plenty of people that are not married, that are in their mid-20s, right? In college and feel very connected and feel part of a community. Or not even in college, feel like they're part of their faith community or whatever it may be. So you should always question stuff. And I'm pushing this and talking about a lot because I really want you to think about this with your second project a little bit, okay?
Yeah, in this, I want to say one thing. Like, we get this result from the quantitative data. So if we also do like qualitative data, maybe we can get more proper results. Like, then maybe we can compare them.
Yeah, yeah, that's a good point, Eva. I agree. All right, let's jump into it. So, what is the hypothesis? What's our null and what's the alternative? What do we got?
Are you dividing what do you do?
Are we comparing between marriage and not marriage, or between or between the categories of alcoholism?
You comparing it, but I don't know.
Yeah, that too. It's married and non-married, and we also have three different categories of dividing people of either they are diagnosed as alcoholics or not.
Yeah,
Yeah,
but
I
what
agree
is
with
the
Zubia.
overall question? Remember, they stated they have a big question. What is the overall question? So Zubi is right. There is these.
Is alcoholism, is it linked to social isolation
Yeah.
and and marital status? No.
Yes. So the null hypothesis says there's no difference. So no difference between alcoholism for married and non-married individuals. So it's the marriage that we're measuring. There is a difference. I see all the turn. The appropriate test is known as the chi-squared. Okay. The decision rule for the chi-squared, the way what we have to do is we have to get how many rows and how many columns. So how many rows do you have in this table?
3.
Okay. How many columns?
5.
Okay. So we don't worry about the total one. Okay.
4.
Okay, 4.
We don't worry about these, right? These don't have values.
3.
So we have 3 columns, 2 rows,
2 rows.
right?
Okay.
It's just the married and not, so these are your rows and these are your columns. So it's just the ones that have, so it should be 2, 3. So this is 2, and this is 3. And so what do we get for our degrees of freedom?
Professor, I want to know like this -1.
Yeah, so these -1s for degrees of freedom we talked about a little bit before.
Okay.
But what they're doing is we're basically having this table. And I need to, those -1 says I'm choosing a point and then everything's switching around it. So
Okay.
I'm taking out one value from the row, one out from the column, and then my degree of freedom is about that.
Okay.
So we're going to get 2 times 1 is 2. Find the chi-squared value from the table, the back of the book, but we will do it a different way. Okay. To compute the chi-squared value itself, we need to get a frequency table for the expected values. And to do that, what you do is, oops, sorry, we take the row total. So let's say we're looking at, let's say we want to find the expected value for married and diagnosed alcoholic. Remember, this is observed. We need expected. So to do that, we're going to take the total married. We're going to take the total married times the totaled alcoholics and divide by 280. And we're going to do that for each one. For undiagnosed married, 116 times 100, divide by 280. Here, it's 116 times 100, divided by 280, and so on and so forth. And we're going to continue to do this. So above is our observed, okay? And I'm doing this on the fly because I think you guys are enjoying that more. So here's our observed. And here's my expected. Okay. So you observe, above is the observed, below is the expected. Notice we don't care about the totals. Cool. And to calculate this chi-squared, this sucks. You're gonna have to do the sum. I'm gonna have to do observed minus expected for each value. So I'm gonna take observed 21 minus 33.1, square that number and divide by 33.1. Do you want to do that 6 times? Anybody want to do that?
No.
Sorry. Samaya, no. You should put that in capitalization, by the way. No, no, we're not going to do this. We're going to do this in R. Excel does this just as well. Okay. And all you're going to do, you can literally copy and paste this and just change these values for the homework. Okay. I'm not joking. I come to this slide when I'm doing my research. So I can just do it in R so quickly because I always forget how to do it. So even myself as a professor, I go to my own notes to recall how to do it. Let's do this in R. And I'm going to explain what each thing we're doing. So first, what we have here is I'm saying M. So this is like my table. And what we're doing is this is 21 is married, alcoholic. 37 is married, drinks too much. 58 is married, not alcoholic. And then the other column is, or the other row is the unmarried. So if we look at M, let me just show you what it looks like. So you want it to look similar to what we have for our frequency table. Okay. Next, all we do, this is the easiest test. All you do is you say, do chi-squared CHISQ dot test of that table. And you're like, well, what does QSQ look like? It even tells you the test. It says it's Pearson chi-squared. It says the degree of freedom is 2. It gives you the chi-squared value and even gives you the p-value. And you're done. You got everything right here. Want to know what's the hardest part? Getting the value into an R. But everything is here. Because you don't want to be calculating this by hand. It sucks. I'm not going to calculate it by hand. And I'm a mathematician, and I like writing and doing monotonous calculations. I'm not going to do it. You're welcome to do it. I want to show you a few things, which are really cool. So what I want to do is I want to see what chi-squared observed is. Well, that's the observed values, right? And I want to see what chi-squared chi-squared expected. And these are the same values that we calculated by hand. So this chi-squared calculation actually still has to do an observed table, which we give it, and an expected value. And not only that, which is cool, is we can pull that information out. Questions on that?
I have a quick question.
Yeah.
When you set up the table,
Yes.
as you were talking about it, I see it, it's cool. At first I wanted to do it wrong. I wanted to do it the exact opposite way and have the rows, 2 rows and 3
Oh, you
columns.
can do that.
Okay.
Notice there's a word here, R. So what that means is I'm saying each one of these I'm binding as different rows. And there's a thing called C bind, so you could say C. So I'm going to do by column.
Okay.
Okay. By the way, I lied to you all. So one of the things that we did, what we just did was 2 or more categories. So we were comparing married and unmarried. If you just want to do one category, it's just like straight up. Okay. But I don't even do an example in the notes. I don't think the book does it very well, but typically we do it with 2 or more categories. Almost never do it with one sample. This is how you're going to want to do it. Okay. If you need help as you're trying to do with the homework, what do? Help me out. Dr. Help me out or reach out to each other.
Professor, I have a question.
Throw it out.
So, okay, we use this chi-square. Like for example, if I have my data, which I have received from my, for example, my survey, and then I have my own observation.
Yeah.
Am I correct?
Yes.
Okay.
And if you don't have something that gives you an expected table from another study that's a bigger study or that has the same similar population or from then what you have to do is if you do the analysis, you'll get your own expected table. Okay.
I totally not understood. Like, I understood partially, I would say.
So what happens is, let's say you're looking at college students, but you decide to look at college students' weight change from freshman year to sophomore year. And you're like, okay, I'm just going to focus on a survey of college students at like DePaul, big university. Mostly those that live on campus. Um, and you're like, but there's been a study that's like nationwide. So you're curious, is there difference between what basically you're observed is what you did at DePaul, but the expected is from that huge data set.
I understood now.
Yeah, and by the way, 99% of the time you won't have that huge data set to compare.
Oh, okay.
All right. In the faith of Halloween, you all got any questions? It's a tiny baby. It's a tiny baby panda. You can't get mad at the panda. Please start this assignment as soon as possible. I know you have other classes, you have other opportunities, but start right away. Okay? Because you're going to get stuck and you're going to get frustrated. You're going to cuss my name. And some of you might have like my picture in a dartboard, but that's okay. Email me. Take screenshots. Say, can I meet with you? Let's find a time. Okay? If we can't find a time, then we'll be doing it through email correspondence. My undergrads do this all the time. I got 4 emails today for their homework saying, did I do this right? Does this look right? I'm like, take it that I tried. One of them, I said, I have no clue what you did. Let's talk in office hours. They came to office hours. Okay? But please do not take this assignment lightly. Even on the email I'm going to send this weekend, I'm going to say, if you have not started the assignment, you're doing yourself a disfavor. Okay? All right. Last thing. I put in some helpful commands and there's this really, okay, this is like an old link. Now I'm curious if it's working. Because it was working when I was talking this summer when I was doing research. Oh, it's still working. So what this link takes you to a blog, which actually goes step by step of how to do t-tests in R, how to do these hypothesis testing in R. Okay. And some of the commands and a way I did it in class and the examples actually come from this blog. Okay. So please take advantage of this stuff. All right. So now the panda is saying goodbye. Again, I know we're ending a little early, but now I'm getting an immense headache and I am starting to lose my voice.
Dr. Hibden, last question.
Yeah, go ahead. Good. The panda's still there.
Okay, so if I am going for the maths model workshop, how can
Yes.
I justify that I went there?
Yeah, so I'm gonna write up in D2L, and you should all go to the workshop. But Hiba, I think you're almost required because you work it.
Yes.
But
Also, I'm sorry.
go ahead, Hiba.
Yeah, I also have a Spark Club, and we are collaborating with Dr. Sositsky.
Mhm.
And so we are going to have our workshop on how to read a research paper on Friday.
Oh, please send that to the class. You have the ability to
I'll
send email to the class. Send it to the class.
okay, I send it to you, and you can forward to the class.
No, you send it to the class. They can
Okay, okay, I'll do it.
don't be embarrassed. And if
Okay,
people can join, they can. If they can't. So what he
yeah,
was, there's a club on campus is talking about how you do research papers and read research papers. Okay. Many of you can't participate, and that's okay. But if you can, great. For the modeling workshop, what it will be required is you'll just have to write a short summary about 3/4 of a page, what you learned, what you found interesting. By the way, I'm one of the original founders of this workshop. I love this workshop. So I'm glad some of you might be going. And modeling workshop, it's statistics and modeling. It's just a great opportunity to see what people do and to learn. And by the way, I'm a math modeler. That is my background. It doesn't mean I model on a runway, right? It just means I use mathematics to describe what happens in the real world. Okay. By the way, it was great to see everybody. And I keep apologizing that we end early, but I know I can't. I won't last another 15 minutes.
Can I ask
Okay, quick
can I ask
question.
a question?
Yeah, go ahead. Tiara, then Bonita.
Oh, so my problem is that I do everything by hand and by calculator because I don't know how to use Excel or RStudio. Can I
Yes,
meet with you to learn how to use those softwares?
of course. It will be virtual for right now because I can't even walk to my office like
Okay.
without like having to sit multiple times and like running out of breath. But is that okay if we meet virtual?
Mhm.
Okay.
It is.
Yeah, and what I would like for you to do is try the homework, or visit REST, as he was saying, because they can help you with that too. But what I'd like for you to start the homework, get to one of the problems where you can't do it by hand. It's mostly the hypothesis testing. And you're like, can we do this problem together?
Okay.
Is that fair?
Yeah.
Yeah, because I think you can do it by hand for the confidence intervals.
Okay.
Yeah, but I'm there to help you. Okay,
All right.
Bonita.
Yes, okay. So next week, no virtual or in person.
No, next week we are still meeting, and
Okay,
then we'll be back to our normal schedule.
okay.
Sorry, it's because like the schedule's screwed up because I got dumb luck, and I'm sorry.
That's okay. I was actually going to request if we can meet next week. So we're not, at least
Yeah,
so I'm not far behind.
yeah. And one thing I'm gonna do next week is again we'll probably end about 8 o'clock, but we can spend that extra hour if you come in with questions, because I know a lot of
Okay.
you are very stressed with time in your schedule, and so Tiara, my other office hours don't work, right? And we can talk from 8 to 9 next Thursday with questions about R and stuff like that. Does that work for some people?
Yes.
Does that work for you, Tiara? Or we can do it separately too?
Yeah.
Just
Yeah. It works. Yeah, it works. but I want to meet with you a couple of times because there's a lot of stuff I wanted to ask you.
Please meet with me. I love office hours. I love meeting with students. I might not be the best professor, but I do love being in office hours. Okay. So yes, we will find a time. Okay. So we just have to be flexible. So email me, say, I want to meet with you Tuesday. You know, if my office hours on Tuesday don't work, let's find a time. Cool.
Okay. Yeah. Thank you.
All right. All right, everybody. This is true for everybody.
Thank you.
Hey, happy Halloween. I should have had a background of a ghost or something. So my kids coming by the way, but I was hiding them. All right. Bye, everyone.
Bye.